Welcome to AI Paper Slop. Today we're looking at a paper titled ResearchStudio-Idea, an evidence-grounded research ideation skill suite from ML conference outcomes. This is by researchers from Nanyang Technological University, Microsoft Research, NUS, and A*STAR. So here is the 60-second core insight for you right up front. We all know that large language models can generate research proposals that sound, highly plausible.
Right. They sound great on paper.
Exactly. But they usually lack the tactical grounding to make those ideas actually viable in a real lab. So this paper introduces an open skill suite centered around a tool called IdeaSpark. By mining 1,947 ICLR, ICML, and NeurIPS papers, specifically from 2021 to 2025, the researchers distilled exactly 15 reusable ideation patterns. And the truly shocking part here, accepted and rejected papers use the exact same patterns.
Yeah, that's the wild part.
Right. The difference lies entirely in the execution. So IdeaSpark uses these patterns, along with their known failure modes, to generate, audit, and differentiate novel ML research proposals that just significantly beat generic LM baselines in quality.
Yeah, and I mean, the broader shift happening here is this whole move away from raw, unconstrained prompting. For the last, couple of years, the community has kind of treated frontier models as these magic oracles.
Just type, give me a novel idea, and hit enter.
Exactly. You just ask for a breakthrough and expect it to work. But this paper proves that highly structured, evidence-grounded workflows are absolutely necessary to actually reign in the latent space of these models.
Which, I guess, brings us to the current flood of these AI scientists we've seen recently, right? You have systems like AI Researcher that try to automate the entire life cycle.
Yeah, from drafting the idea to writing the PyTorch code all the way to compiling the final PDF.
Right, but the authors argue that these end-to-end systems generally just produce incremental, homogeneous, or deeply flawed ideas. I mean, to use an analogy, it seems like these current autonomous systems are incredibly efficient, automated factories. They can manufacture a product perfectly from start to finish, but they have absolutely no idea what product the market actually needs.
That's a really good way to put it.
They're blindly building infrastructure for problems that just don't exist.
Right. They suffer from what the authors call the Ideation-Execution gap. So current autonomous agents, they've mastered the syntax of writing a paper, but they completely lack that tacit laboratory knowledge and, scientific taste.
Scientific taste, yeah. That's so hard to quantify.
It is, because an LLM's default state is heavily biased by its pre-training data, which means it tends to basically regress to the mean of popular, already solved problems. So this paper really zeroes in on the first mile of research.
The very beginning.
Exactly. Before a single GPU is even spun up or a single line of code is written, a researcher has to ground a problem in the literature. They have to identify a real, unresolved bottleneck and evaluate all the structural risks.
So to fix this first mile problem, the ResearchStudio-Idea suite introduces 3 specific tools, right?
Yep, 3 tools.
You've got Paper Search, which is their multi-source literature grounding. Then there's Scoop Check, which is a prior art collision checker. And finally, IdeaSpark, the actual end-to-end workflow generator.
Right.
But, to build an automated R&D department like this, you have to fundamentally teach the AI what a good idea actually looks like computationally. And they mined nearly 2,000 papers.
Yeah.
If they're just looking at raw text, a paper on diffusion models is naturally going to cluster with other diffusion papers.
Yeah, exactly. Just based on keywords.
Right. So how did they extract the underlying tactical logic without just grouping everything by topic?
So this extraction methodology is honestly the most elegant part of the paper. They collected orals, high-cited papers, and, this is crucial, they also collected rejected submissions.
Oh, wow. Right.
Yeah, so they fed the title, the abstract, the introduction, and the actual peer reviews of these papers to Claude Sonnet 4.6. And the instruction was to extract a 12-field innovation signature.
What does that signature look like?
So it breaks down things like the approach, the key step, the cognitive barrier that made the solution non-obvious in the first place, and the trigger condition. But the real forcing function here was making Claude rewrite all these fields to be completely domain agnostic.
Okay, wait, so they forced the model to strip out terms like self-attention or latent space.
Exactly.
They're isolating just the cognitive maneuver itself.
Right, because that is the only way to cluster by strategy rather than just topic. So once they had these domain-agnostic signatures, they embedded them using OpenAI's text embedding 3 large model, and then they applied density-based clustering.
Okay, and for those listening who maybe don't work with clustering algorithms every single day, Density-based clustering doesn't just slice the data into predefined chunks, right?
No, it looks for continuous, tightly packed neighborhoods of data points in a high-dimensional space. And by doing this, they found 31 distinct subpatterns, which then organically consolidated into 15 high-level ideation patterns.
Okay, I have to push back on that final number just a bit.
Sure.
Boiling down the entirety of complex ML research across all these massive conferences over 5 whole years into just 15 tactical patterns feels, I don't know, kind of reductive. Are we really saying human innovation in machine learning is that narrow?
Well, the authors actually address this directly. The number 15 is not supposed to be some canonical, universal ontology of all human thought, right?
Right.
It's simply the operational granularity produced by this specific pipeline. But honestly, if you look at the patterns themselves, they are deeply recognizable to anyone who spent time in a lab.
Like what? Give me some examples.
So you have patterns like audit and pivot and assumption. Another one is reframe as a solvable object, or characterize a limit, then surpass it.
Okay, yeah. I've definitely read 100 papers that fall under characterize a limit, then surpass it.
Right, we all have.
But stripping away the domain vocabulary reveals something pretty profound there. Like researchers working in computer vision and researchers working in multi-agent reinforcement learning are frequently executing the exact same cognitive moves.
Exactly, they just use different math to do it.
Which sets up, honestly, the most counterintuitive finding in the entire paper, what they call the reject paradox.
Yes, the reject paradox is fascinating.
Right, because if we have these 15 patterns that supposedly define ML research, the natural assumption is that rejected papers must live in some completely different, bizarre strategy space.
Yeah.
You'd think bad papers are trying weird, out-of-bounds maneuvers.
But the data points somewhere else entirely. When the researchers clustered the rejected papers entirely on their own, they mapped perfectly back to 11 of the 15 main patterns.
Wow.
Yeah, so the underlying strategy is not what triggers a DEST reject. The difference lies almost entirely in contrastive failure modes.
So it's basically like two chefs using the exact same recipe for a souffle.
Okay, yeah.
The recipe, the ideation pattern itself, isn't what makes one collapse in the oven. It's the execution. Or, it's like building a bridge. An accepted paper identifies a weak wooden beam, replaces it with structural steel, and then provides the exact mathematical load-bearing tolerance. But a rejected paper identifies that exact same weak wooden beam, but replaces it with paper mache. Or they just eyeball guess the tolerance, and the whole thing collapses when the tier reviewers drive a truck over it. The strategy of replacing the beam was correct, but the execution was completely ungrounded.
That's a perfect analogy. Let's actually apply that to the audit and pivot and assumption pattern they found. In a highly rated accepted paper, a researcher will identify a load-bearing assumption in the field. Say that a certain variable distribution must be Gaussian.
Okay.
They will relax that assumption, pivot to a new model, and then this is the critical part. They will actually verify that this relaxed assumption holds in real-world data. To finalize the structure, they provide what's called a tightness certificate.
A tightness certificate. And that usually looks like a matching lower bound or like a strict algebraic equivalence, right?
Exactly.
Something that mathematically proves the audit assumption was the actual barrier, not just some symptom of loose analysis.
It's the mathematical proof of the steel's load limit, going back to your bridge analogy.
Right.
Now observe a rejected paper utilizing that exact same audit and pivot strategy. They'll relax an assumption, sure, but then they substitute it with an equally strong prior.
Or an entirely unverifiable one.
Yes. Or they just completely fail to prove that the original assumption was the bottleneck in the first place. And reviewers spot this instantly.
So the implication for IdeaSpark here is just massive. It isn't just a brainstorming buddy saying, hey, try auditing an assumption. It's an active guardrail.
Exactly. It's preventative.
It's warning the LLM during generation, do not substitute this for an unverifiable prior, because that exact failure mode is how 80 other papers got rejected last year.
Yeah, the system actively uses these contrastive failure modes as a sort of quality gauntlet. It doesn't just generate ideas blindly, it audits the generated idea against the specific historical failures mapped to that exact pattern.
Okay, so that covers how to avoid a rejection.
Yeah.
But getting accepted isn't exactly a monolith either. Even among accepted papers, what constitutes a quote-unquote good idea seems to depend heavily on who you are actually asking.
Oh, absolutely.
The paper highlights this massive split between the program committees like the reviewers at ICLR or NeurIPS and the broader ML community.
This split reveals a really severe acceptance bias. So the researchers tracked two distinct markers of success in their dataset. First, oral presentations, which represent the absolute pinnacle of program committee preference. And second, high-citing papers, which represent the community's preference and actual adoption out in the wild.
And these two preferences are nearly orthogonal to each other, right?
Pretty much, yeah.
So let's break down who likes what. For the listener thinking about their next paper, this is huge.
Okay, so program committees heavily favor the audit and pivot and assumption pattern. It is highly oral enriched. Reviewers love to reward structural, analytical insights that come with bounded guarantees.
Right, they want to see the math tightly closed.
Exactly. However, the broader community actually cites that pattern much less than you would statistically expect. On the flip side, consider the pattern unify heterogeneous inputs into one space. Think of those massive cross-modal alignment papers where someone figures out how to map text, audio, and video into a single latent space.
Oh, the community loves those.
Yeah.
Because they provide usable, downloadable infrastructure.
Yes.
Like they become the open source foundation for 100 other downstream projects.
But program committees rarely elevate those unification papers to orals. They might view them as, great engineering achievements rather than theoretical breakthroughs.
So for you listening, think about the last architecture or theory paper you drafted. Were you optimizing for the program committee to get that prestigious oral presentation on your CV? Or were you optimizing for the broader community to rack up citations and open source usage?
Because this data strongly suggests you might not be able to easily optimize for both using the exact same tactical pattern.
Right. And IdeaSpark actually surfaces this exact metagame to the user, doesn't it?
It does. Because it has all this historical data embedded, it can flag a proposed direction and say, hey, this path is highly favored by reviewers for orals, but historically it struggles to gain traction as shared infrastructure.
It makes the invisible biases of the research community completely transparent before you commit months to a project.
Exactly.
Okay, so knowing the patterns, the failure modes, and the audience biases is half the battle. But how does IdeaSpark physically construct a viable proposal at runtime? Because a single tactical pattern probably isn't enough to carry a state-of-the-art NeurIPS submission these days.
No, definitely not. And the composition data is really telling here. Nearly 60% of the papers in the dataset use exactly two patterns in tandem.
Two patterns.
That is the dominant mode across orals, high-cited, and rejects. For instance, combining audit and pivot and assumption with characterize a limit then surpass it is one of the most highly oral enriched combinations they found. Implementing that specific combo skyrockets the probability of an oral presentation by over 20 percentage points.
I mean, it makes sense why reviewers love that. You identify a flawed structural assumption and then mathematically prove a strict improvement over the limit it imposes.
It's the holy grail for a reviewer.
But when an LLM tries to stitch two distinct patterns together, it usually hallucinates or it just loses the thread entirely. So how does IdeaSpark mechanically restrain the model during the generation process?
So the pipeline operates in 4 distinct phases to force constraint. Phase 0 is literature grounding, where it dynamically pulls recent, relevant, full-text papers using that paper search tool.
Getting the actual text, not just summaries.
Right. Then phase 1 is bottleneck identification. It doesn't just look for a topic gap, like, noticing no one has applied a specific transformer to a specific biology data set. It actively scans the text snippets to find a structural gap.
Wait, what does a structural gap look like in this context?
For instance, recognizing that applying that transformer inherently breaks the continuity assumption in the biology data's latent space.
Oh, I see. So finding the actual friction point, not just an empty space on the map.
Precisely. Then phase 2 is pattern-guided ideation, which is selecting the right tactical patterns to attack that specific structural gap. And finally, phase 3 is the quality gauntlet and scoop check.
I really want to highlight scoop check because the mechanics of it are so critical. It isn't just running a quick keyword search on ArcGIS to see if your title exists.
No, it's much deeper.
It decomposes your generated idea into 3 axes: problem framing, core mechanism, and application. And then it runs targeted semantic searches against recent literature to see if anyone has published your exact mechanism in the last 6 months, even if they used slightly different terminology.
Yeah, it acts as an automated defense against parallel discovery, which, as we know, is a massive issue in ML right now.
Oh yeah, constantly getting scooped.
But the ultimate output of this 4-phase pipeline is an idea card. And the idea card contains one field that I think fundamentally changes how we interact with automated research, the falsification field or the kill switch.
Let's focus entirely on this kill switch for a moment. Why is it absolutely vital to structurally define exactly how an idea fails, like designing a negative control, before you even allocate a single GPU to test the hypothesis?
Because it forces rigorous experimental design up front, which LLMs naturally want to
I
avoid.
just want to say yes.
Always. The paper gives a brilliant example of a generated idea card for long context reasoning in reinforcement learning. The proposed idea involves redistributing a scalar advantage score into a per-phase credit density.
Okay, so a complex, localized credit assignment mechanism.
Exactly. Now, the kill switch for this explicitly requires a negative control. Permute the phase labels so that the exact same credit density lands on completely random spans of the sequence.
Meaning, if you run the negative control and the model's accuracy still survives or improves, then the performance gain came from generic variance reduction.
Yes.
It didn't come from your clever, localized credit assignment.
It proves you didn't actually solve the problem you claim to solve. If an LLM cannot generate a valid, mechanically sound kill switch for its own idea, the idea is fundamentally untestable.
That is so important. It stops the AI from claiming victory just because the loss curve went down. Because previous AI scientists, they generate an idea, write a script, and if the loss curve drops, they just start drafting the abstract.
Right. Correlation isn't causation, but they treat it like it is.
Exactly. The kill switch demands scientific falsifiability. It demands proof of the mechanism itself.
It honestly brings the scientific method back into automated research.
I have to imagine, though, that if you pit this highly structured, red tape-heavy pipeline against a raw frontier model like GPT 5.5, the raw model is going to win on pure, unhinged creativity, right? Does adding all this structural grounding actually result in a fundamentally better paper, or does it just create a safer, kind of boring one?
Well, they tested this exact hypothesis. They used a blind, automated judge evaluation on 100 problem seeds drawn directly from ICLR 2026 guidelines.
Okay, so very current problems.
Very current. They pitted IdeaSpark against Claude Opus 4.8, testing it with both bare prompts and self-generated prompts, and against GPT 5.5 with just a bare prompt. IdeaSpark consistently achieved the highest quality rank across all 21 research domains evaluated, while still maintaining highly competitive novelty scores.
Wow. And when GPT 5.5 was left to its own devices, it fell into a very specific failure mode, didn't it?
Yeah.
The novel but empty trap.
Yeah, the novel but empty trap. Because frontier models optimize for the prompt they are given. If you ask GPT 5.5 to generate a highly novel research idea, it will maximize the statistical uniqueness of its output.
It'll just give you the weirdest thing it can think of.
Basically, the novelty scores for GPT 5.5 were off the charts, but the quality and feasibility scores just plummeted. It generated ideas that were entirely disconnected from the actual physical or logical bottlenecks in the literature.
Right.
It hallucinated mechanisms that sounded incredibly creative but were fundamentally impossible to implement or verify.
So purely optimizing an LLM prompt for novelty is a trap. If your proposed idea isn't structurally grounded in the literature and it doesn't actively account for the contrastive failure modes of the past, you are literally just generating highly original hallucinations.
Exactly. Surface novelty and proposal fluency are incredibly weak proxies for useful ideation.
Yeah, the fluency of the generated text just tricks the human evaluator into thinking the underlying logic is sound. And IdeaSpark breaks that illusion by demanding evidence at every single step.
Right, it forces you to prove it.
So how does this change your day-to-day workflow in the lab as a listener? Even if you don't integrate the actual IdeaSpark software today, the underlying methodology is immediately applicable. When you are reading a paper or drafting your own, start identifying the cognitive moves. Are you auditing an assumption? Are you unifying heterogeneous inputs?
And once you know the pattern, look for the tightness certificate.
Yes. Are you actually proving your mechanism, or are you just guessing at the load-bearing tolerance? And most importantly, before you write your next training script, force yourself to physically write out a kill switch. Define exactly what a negative control looks like for your new architecture.
By internalizing these 15 patterns and their specific failure modes, you gain the ability to self-audit your own research proposals.
It's an immune system.
Exactly. It acts as an immune system against spending 6 months going down a dead-end path simply because the initial ideas sounded plausible.
Which leaves us with a provocative thought for you to mull over. The IdeaSpark dataset is built on ML conference outcomes from 2021 to 2025, right? So it is a perfect distillation of human research patterns. But if AI researchers increasingly rely on tools like IdeaSpark to generate their next wave of proposals, will these 15 human patterns simply compound and reinforce themselves in an endless automated feedback loop?
That's a scary thought.
Or As these autonomous systems become more sophisticated and start generating their own intermediate steps, will an entirely new set of AI-native research patterns emerge. Like strategies that are so alien and so structurally complex that human reviewers don't even possess the vocabulary to categorize them.
We might not even recognize it as research.
I guess we'll find out what the submissions look like at ICLR 2027. Thanks for joining us on this deep dive into the source material.